Okie dokie, children. Just Miss Jensen. We're on 4.7. L'Hopital's rule. You know, how you say this guy's name, we don't really know. But look, I found this cute little thing that's like, see, the limit of a determinate form and L'Hopital's and me. I think it's cute. Anyways, I really enjoy L'Hopital's rule, actually. I think it's quite entertaining. So, yeah, let's get into it. So, suppose f of a equals 0 and g of a equals 0. In this of limit of as like x approaches a of f of x over g of x equals 0 over 0, or infinity over infinity, then L'Hopital's rule allows you to apply the following. All right, and so oh cute. So 0 over 0 and pi or infinity over infinity is not like good. These are called indeterminate. I don't know if I'm spelling this right. These are indeterminate forms of stuff, and there's definitely a lot more of these out there, but we only focus on 0 over 0 and infinity over infinity in this class, apparently, so, I mean, cute, I guess. Limit as x approaches a over the derivative of f of x, oh my goodness. Limit as x approaches a of derivative of f of x over the derivative of g of x. And yeah, that's just a whole bunch of mush. I'm actually going to do an example now. So here we have a limit as x approaches negative 5 of this, thing. So first thing first, the first thing you want to do is actually double check it. Check if you can use the rule. This is a little bit annoying, but a lot of the times you won't even need to use the rule because, it doesn't lead to an indeterminate form. And the way you check this is by taking the limit of the numerator and the limit of the denominator. So the limit as x approaches negative 5 of x squared minus 2x minus 35. And the limit as x approaches negative 5 of x plus 5. Basically, you'd plug in the negative 5 for x, and this would give you 25 plus 10, which is positive 35 minus 35, that gives you 0. And once you do this, negative 5 plus 5 also gives you 0. So ding, 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 we have a winner, stars on stars. This is an indeterminate form, so L'Hopital's rule actually will work. So now you're going to derive. You're going to take the derivative of the top and the numerator and the denominator of the limit. So once I derive this puppy, we get lim as x approaches negative 5 of, it goes to 2x to the power rule, same for this, minus 2, and then constant rule, 35 is 0, makes the derivative of 35 0, and then x just turns into 1 due to product rule, and the derivative of 5 is 0 because of the constant rule. So we've taken the derivative, and now we're going to kind of pause. Michelle forgot what she was doing. Just pause. Okay, we're back. And then we're going to basically take the limit of it. So then 3, you just take the limit. It can't get much more difficult than that, right? You take the limit. And so once you do that, you get 2, negative 5, minus 2 over 1, and that gives you a number. Perfect. Now it gives you negative 12 over 1, which is just negative 12. Cool beans, and there's the answer. Oh, that definitely took over too much space on this side. Equals negative 12. All right, perfect. A couple things to know here. Like, let's say you take the limit again. Over here on the second derivative, or at step 2, you take or step 3, I apologize. You take the limit again, and it gives you the indeterminate form. You do the rule again, which I think might be, I think that actually might be the case for this next problem, but we'll see. All right, so we're doing this again. Step 1 is to check. So we have limit as x approaches infinity of 2 infinity squared equals infinity. I recommend y'all review all of y'all's infinity rules if you forgot them, because I have. Infinity of e to the 2x. I apologize. This needs to be an x. I kind of plugged it in my brain. E to the 2x equals also infinity. And infinity over infinity, again, is indeterminate. We got yourself a winner. So we can use L'Hopital's now. It actually works. Cool beans. So now we take the derivative. Derivative of 2x squared is going to be 4x, thanks to product rule. And derivative of this, thanks to chain rule, is going to be 2x. No, 2x. It's just 2. 2 times e to the 2x, because the derivative of e to the x is itself, and then times the argument, for which is chain rule, as limit approaches infinity. That's what you get. And so now we go ahead, we do the bottom and top again. So we try to take the limit. So the limit of, as x approaches infinity, of 4x equals infinity again. And the limit as x approaches infinity of 2e to the 2x equals infinity again. And so now, once again, you have another indeterminate form, and I was correct. You have to do L'Hopital's rule again. And this is your best friend. Derivative, you take the derivative of this one here. So you have 4 over 4e to the 2x. And you're taking the limit as this. Alright. And so a little thing here, you can actually stop once you get, let me get some stars. You can stop once you get a constant on the numerator. And I'll show you why in a sec. So basically you can stop here because you would get 4 over infinity. And 4 over infinity of anything is actually going to give you 0, because the denominator is getting infinitely larger, and that basically just give you 0 in the end. So yeah, that's the answer for this one. Alrighty, folks, and that is it for Unit 4. Thank you.